Alright, in this video here we are going to be talking about net change and average rate of change. Alright, so in this video I'm just going to explain what net change, what average rate of change are, and kind of what the formulas are for those, and then I'll do another video where I actually do some examples of finding and calculating the net change and the average rate of change. Alright, so first off, the net change of a function y equals f of x from x equals a to x equals b is f of b minus f of a. Right, so when we're talking about the net change of a function, it's always between two x values, or in between two input values. From this input value to this input value, how much are the outputs changing? Right, so that's what I put down here in parentheses. Right, that the net change is really just the difference in the outputs from two different input values. Right, so I drew a little example over here. We have the function here in that purple curve that's going up there, and I have two x values from x equals a to x equals b. The net change of the function is from f of a up to f of b. Right, so this is my f of a is the y coordinate of this point. F of b is the y coordinate at this point here. Right, remember, when I plug those x values into the function, I get the output value, which is the y coordinate of that point on the graph. Right, so the net change is just the difference in those two y values, which is represented on this side over here, this little vertical dotted line, f of b minus f of a, right, just the difference in those two outputs, the difference in those two y values, that gives you your net change. All right, so net change, all it is, right, the difference between the two y values. And when you're doing net change, you always do the second, or you do the y coordinate from the second x value minus the y coordinate from the first x value, right? So it's always f of b minus f of a. Or if you want to think of it another way, f of b is like your y2, and the f of a is like your y1. All right, so you're always doing the second one minus the first one, the one on the right minus the one on the left. All right, now in this case, my net change would be a positive number, but it doesn't have to be, right? If my function is decreasing and I do f of b minus f of a, I could have a negative net change, right? Which just means between one point and the next, the function is decreasing in value. All right, so a positive net change means that the function is increasing. A negative net change means that the function was decreasing. All right, so that's the net change. Again, just the difference in the outputs, the difference in your y values from one point to the next. That's all net change is. Right, which is related to average rate of change of a function. Right, the average rate of change of a function y equals f of x from x equals b to x equals a. So again, from one x coordinate to another x coordinate, the average rate of change is f of b minus f of a divided by b minus a. All right, so notice, when we're doing average rate of change, we have a fraction here. The numerator of that fraction, f of b minus f of a, that's your net change. Right, so basically, the average rate of change of a function between 2 points, between two x values, is the net change, the difference in their y values, divided by b minus a, which is the difference in the two x values. Right, so we already discussed when we're doing net change, right, the f of b minus f of a, that's the difference in your y values here. That's that vertical line, which is the rise from one point to the next. Right, if this is my starting point over here at x equals a, and this is the ending point over here at x equals b, the difference in y values, the f of b minus f of a, gives me my rise, right? How far is the graph moving up or down from this point to that point, right? Just the difference in the y values. And then the b minus a, that's that horizontal distance there from this point to that point, right? The difference in the x values gives me that horizontal distance, which is the run, right? Which should look familiar from when we talked about the slope formula. Right, the average rate of change is really just the slope of the line that connects these 2 points on the graph. Right, the graph itself is a curve, right? It's not a straight line. But if I just put those 2 points on the graph and I draw that straight line here connecting those 2 points, which we call that a secant line. A secant line is a line that intersects a curve more than one time. Right, so it kind of just goes through the curve. Right, so the slope of that secant line between those 2 points, that is the average rate of change of the function between those 2 points, right? So the f of b minus f of a, that's the difference in my y values. That's really just y2 minus y1, right? I'm just taking the second y value and subtracting the first y value. That's y2 minus y1. And the b minus a in the denominator, well, that's my second x value minus my first x value. That's just x2 minus x1, which you should recognize as the slope formula. Right, so average rate of change is really just calculating the slope of a line that connects 2 points. Right, the graph itself usually is not a line, but if you just put the 2 points on there and draw a straight line between those points, if you calculate the slope of that line, that's the average rate of change of a function between those 2 points. Right now, if your function is not a linear function, then the average rate of change will be different depending on which x values you pick. Now, like if I pick this point here and this point there, the slope of the line that connects those 2 points, that gives me the average rate of change, not for the entire function, but just between those 2 points on the function. Right? If I were to pick this point down here and then this point up here, that would give me a completely different average rate of change, because when I draw the line to connect those 2 points, that line is going to have a different slope from the one that's up here. Right? So the average rate of change is different, for a function depending on which x values you pick, unless you have a linear function. Because if you have a linear function, which is just a straight line, no matter what 2 points you pick on the line, it always has that same slope. All right, so that's net change and average rate of change. Remember, net change is just the difference in the output values, f of b minus f of a, or more simply, it's just y2 minus y1. The second y value minus the first y value. And then the average rate of change, they give us this fancy formula for average rate of change, f of b minus f of a over b minus a. But really, that's just y2 minus y1 over x2 minus x1. Right? The average rate of change formula, they're putting the slope formula into the function notation. Like instead of y1, they're calling it f of a. But really, it's just y1. Right? Y2 is the same thing as f of b. So anytime you're asked to do average rate of change, you don't really have to use this fancy formula. It's like one more formula you would have to memorize. If you just remember that average rate of change is the slope, just use y2 minus y1 over x2 minus x1. Should be a formula that you already know. And then anytime they say average rate of change, just say, oh, that's slope. Let me use the slope formula. All right, and then you don't have to bother yourself with memorizing that other formula there. All right, so that is average rate of change and net change. And I'm going to do another video now where I do a couple examples of calculating the net change and the average rate of change. So make sure you check those out so you can see how to actually do a problem that involves this stuff.